In the last lesson, we went over how to factor polynomials with greatest common factors. So sometimes you get to a polynomial that doesn't have a greatest common factor, so we want to still be able to factor it. So that's what we're going to cover today is we're going to go through one method if you have certain types of polynomials that we can factor them even without a GCF. So our learning goal, right? I can factor trinomials in the form of x squared plus bx plus c. I want you to write this down too. That means this polynomial is a quadratic, right? The highest power is 2. And it's a trinomial. It means 3 terms. We've talked about both of those before. So whenever you have a quadratic trinomial, you can still look for a common factor. But if there isn't one, then we're going to try this other method. So just to kind of introduce it, I want to go back to multiplying because we know factoring is just multiplying backwards. It's saying what do we multiply together to get an answer. So if I took this and I multiplied, x plus 2 times x plus 5, right, I'm just going to do the distributive property, x times x squared, x times 5, 5x, 2 times x, 2x, 2 times 5, 10. We can combine those two middle terms. I end up with x squared plus 7x plus 10. So notice this down here, this is a quadratic trinomial. So if I want to go backwards and factor it, it means I want to get back up to this part up here. So just think about where everything came from. If I gave you this and asked you to tell me what to multiply together to get it, look where all the parts came from up above, right? The x squared came from multiplying the x and the x. The 10 came from multiplying the 2 and the 5, the last two. The 7x in the middle came from multiplying the outside 2, the 5x, and the 2x and adding them together, which gives us the 7x. So kind of think about that. I'm going to go through and show you how to factor problems like this, quadratic trinomials. But think of, really, we're just multiplying backwards. So you want to focus on what we did when we did multiplication. Okay, so I had this problem. It's x squared plus 8x plus 15, and I want to factor it. Check for a GCF first. There aren't any common factors. Okay, so the next thing we're going to do is try factoring it. We're going to think back to what we did here. Okay, we have these two sets of parentheses, and you had a binomial times a binomial. So we're going to do this. We're going to try just thinking backwards. So we're going to do two sets of parentheses. Think about it. This times this has to give you the x squared. Well, that's got to be x times x. When I multiply these two numbers, I get 15. Well, off to the side, I'm going to make a list then of things I can multiply together to get 15. I think there's just two pairs. We have 1 and 15. We have 3 and 5. So either one of those two, if I put a 1 and a 15 there, I would get 15 when I multiplied it, or if I put a 3 and a 5. So we have to figure out what the middle number would, that middle number is going to tell us which one to use. So go back to here. Right, this 7x right there in the middle came from adding those two together, right? 2 times 5 is 10, but 2 plus 5 is 7. So we're going to look for which ones add up to be the middle term. The middle term is 8, so 3 plus 5. So I'm going to put in here plus 3 and plus 5. So I want you to see how this works, right? That's the answer, right? That's what I multiply together to get the original polynomial. The reason why it works, though, is this. Just multiply it out with me. It's x squared, right, plus 5x, plus 3x, plus 15, right? 3 times 5 is 15. You add those together. 5x plus 3x gives us the 8x in the middle. Hey, this is, again, a quadratic trinomial. The highest power is a 2, and it's got 3 terms. So if it is a quadratic trinomial, do your two sets of parentheses, and you're just thinking backwards with that multiplication. Let's do another one together, then I'll have you try one on your own. So you have r squared plus 11r plus 24. So recognize there's no common factor, and it is a quadratic trinomial. So if that's the case, do your two sets of parentheses. We're just thinking backwards. That times that gives you r squared, so r times r. That times that has to equal 24. So make your list. This is something that some of us struggle with. Like, some of us are great with our multiplication facts. Some of us aren't. If you aren't, just be methodical about it. Right? I know 1, you can always do 1 and the number, 1 and 24. Try 2. So grab a calculator. 24 divided by 2 is 12. Try 3. 24 divided by 3 is 8. Try 4. 24 divided by 4 is 6. You could try 5. 5 doesn't go into it evenly. And then we're back to 6, which we've already done. So that should be our entire list. That's the list of all of our factors. So you could be methodical about it. Just start with 1, 2, 3, 4, and you're just using your calculator to check it. Now I have 4 different combinations. I'm not sure which one works. To tell, I'm going to look at that 11R. When I add up the two terms, the two middle terms, it has to equal 11. So which one of these add up to be 11? I'll say that's 25. That's 24. 3 plus 8 is 11. So plus 3 and plus 8. Okay, there is our factored form. I want you guys to try one. So pause the video. Actually, let me give you a different one besides this. Let's do this one. Let's do x squared plus 13x plus 12. So pause the video, try factoring that, and then play the video again, and I'll go through it with you. So this is a quadratic trinomial. As soon as we see that, we do our 2 sets of parentheses. X and x, right? That gives me the x squared. When I multiply those two numbers, it has to equal 12. Let's make our list. So 1 and 12, 2 and 6, 3 and 4. Then I'm back to 4. There won't be any more. So I want the ones that add up to be 13. Well, that's 1 and 12. 1 and 12 add up to be 13, so it's going to be plus 1, plus 12. And just a side note, it doesn't matter if you write it that way or this way. Multiplication is commutative, which means you can switch the order and you'll still get the same answer. So it doesn't matter which order you put those in. It can get a little bit trickier when we start mixing up signs. So all 3 examples we did had pluses. This one has a minus in the middle. The steps are still the same. Check for a greatest common factor, and there isn't one. There's not going to be any on any of these examples we do. Then confirm it's a quadratic trinomial, right? Highest power is a 2, and it's got 3 terms. So you do your 2 sets of parentheses. Okay, now we're just working backwards. What times what gives me x squared? Has to be an x and an x. Now this is the part that gets a little bit tricky. When I multiply those two, it has to give me a positive 24. Well, to get a positive 24, it could either be 2 positives. It could also be 2 negatives. Well, if I add 2 positives together, it will not equal a negative 11. But if I add 2 negatives, that could happen. So instead of looking for 2 positives, I'm going to look for 2 negatives. So I'm going to go negative 1 and negative 24, negative 2 and negative 12. We made this list before, so make that same list. I want the ones added to be negative 11. It's those two right there. So my answer is minus 3 and minus 8. Right, when I times those, I get a positive 24. When I add those, I get a negative 11. So you got to think about those signs. You got to think about those multiplication properties we've learned way back at the beginning of the trimester. Right, if you multiply 2 negatives, you get a positive. Or if you multiply 2 positives, you get a positive. Then you have to look at the middle term and decide, is it going to be 2 positives or is it going to be 2 negatives? Let's do one more of those. In fact, you guys try this one. Y squared minus 6y plus 8. So pause it, try it. All right, now I'm going to go through it. So again, quadratic trinomial, 2 sets of parentheses, y and y. I want the factors of a positive 8. Well, to get a positive 8, that means I can either multiply 2 positives or I can multiply 2 negatives. It has to add up to be a negative 6, so it has to be 2 negatives. So it could be negative 1 and negative 8. See, 2 goes into 8, so negative 2 and negative 4. 3 doesn't, and then I'm back to 4. Okay, I want the ones that add up to be negative 6. Negative 2 plus negative 4 adds up to be negative 6. So there's a couple possible combinations. If it's a plus plus, you'll end up with 2 positives. If it's a minus in the middle and a plus for the last term, you'll end up with 2 negatives. There's one more case, and that is if you have a minus at the end. So if you look at this one, it's x squared plus 2x minus 15. Okay, same steps. Do your 2 sets of parentheses. Right, this is a quadratic trinomial. X and x. Now just think about this for a second. We know these properties. If I want to multiply those, it has to equal a negative 15. The only way it can equal a negative 15 is if I multiply a positive and a negative. So now my factors have to have opposite signs. So let's try this. I could do negative 1 and 15, negative 3 and 5, and I want them to add up to be a positive 2. Well, the one that works is right there. Negative 3 plus 5 is a positive 2. So minus 3 plus 5. So we don't have to, you can memorize these. I think it's easier just to think it through, right? To get a negative 15, they have to have opposite signs when you're making your list of factors. Let's do another one. We'll do one of these and I'll have you try one. So let's do A together, and then you guys can try B. So two sets of parentheses, and again, we're just thinking of that whole multiplication process. We're just doing it backwards. When I multiply those two, I get negative 36. Now, that means, right, my two factors have to have opposite signs. If I multiply them, I get a negative. So let's do a 1 and a negative 36, a 2 and a negative 18, a 3 and a negative 12, a 4 and a negative 9. 5 doesn't go into it. We could do 6, 6 and a negative 6. So we've got 5 different combinations here. We've got to figure out which one works. We want the one that adds up to be a positive 9. That one adds up to be negative 35. That one adds up to be negative 14. Hey, if I do this one right here, that one adds up to be a negative 9, 3 plus negative 12. Well, I want a positive 9. So if this happens, if you get the right integer with the opposite sign, all I have to do is flip these. I'm going to change the 3 to a negative and the 12 to a positive. Now when I multiply those, I get negative 36, but when I add them, I get a positive 9. So I have a minus 3 and a plus 12. Right, I times those, negative 36, I add them, and I get 9. So that's my combination right there. All right, you try B. So pause it, try B, and then we'll come back and go through it. We're setting it up the same way, right? C and C. I have to get a negative 21. That means they have to have opposite signs. So negative 1 and 21, negative 2 and, 2 doesn't go into it, sorry. Negative 3 and 7. 4 doesn't, 5 doesn't, 6 doesn't. We're back to 7, so we're good. All right, now if you look at those two add up to be a positive 4. So this is what we talked about. If I change that to a plus 3 and a minus 7, now I still get a negative 21 when I multiply them, but now they add up to be a negative 4. So plus 3 minus 7, there's our factored form. Hey, the last example I wanted to do with you is if you have two variables. So I'm going to skip ahead just a little bit. I'm going to look at this problem right here. So I have x squared plus 6xy minus 55y squared. So I have both an x squared and a y squared on the ends, and in the middle I have both an x and a y. These really aren't that different. There's just a little trick, so I wanted to show you one of these. We're going to start by doing our two sets of parentheses. We're going to put an x there and an x there, right? X times x gives me x squared. Now if I have a y squared on the end, that means there has to be a y there and a y there. So it's going to put a y at the end there. And I'm still going to have to add the correct number there and there. The rest of the problem then is just like we've done before. So now ignore the x's and the y's. I'm just going to take negative 55 and list all of its factors. I want the ones that add up to be a positive 6. Okay, so we're going to go, we have to have opposite signs here, right? When we multiply them, we get a negative. So it could be negative 1 and 55. 2 doesn't go into it, 3 doesn't. 4 doesn't. You could try 5 and 11. 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't. Okay, so these are our possibilities. We want it to add up to be a positive 6. Those two right there, negative 5 plus 11 add up to be a positive 6. So come up here. It's going to be x minus, and the 5 just goes with the y. So x minus 5y, and x plus, and the 11 just goes with the y there. X plus the 11y. So there's our factored form. So if you do have a y squared or another variable on the end, you just include both of those with those second terms. The reason why it works, just watch what happens. If I were to multiply this out, that would be x squared. That would be 11x times 11y is just 11xy. Times those together, so minus 5xy. Times those together, minus 55y squared. So notice in the middle there you end up with those xy's. 11 minus 5 is 6. And there's our, so this is the correctly factored form, right? That gave us the answer. So you could do them with two variables also. Okay, these again are quadratic trinomials. Again, don't forget about greatest common factors. On the assignment, the first section has greatest common factors, just to review that. But if there is not a greatest common factor, and it is a quadratic trinomial, like highest power is a 2, and it's got 3 terms, then we're going to try this this second method to factor these. Thanks, guys.